So problem number 2. Problem number 2 says determine all the roots of f of x is equal to x square plus 3x plus 2 which belongs to z6 of x. Now this is a special case where they are mentioning the modulo of 6. Right. So now you can ask me, why can't we do the same procedure as we did in the previous problem? Since even here we have a quadratic equation, so can we substitute this quadratic equation? Where can we solve this quadratic equation and get the values and check? No, we should not do that here. Why? Because they haven't told us whether it's over R or whether it's over Z or C or whatever it is. Here they have clearly mentioned it as the modulo of 6. So I'll tell you how to find the modulus of 6. Right. So step by step process. Please pay attention. It's a very important problem. So what do I do? F of x is equal to x square plus 3x plus 2. Right. So first I'm going to take the polynomial. What is given I'm going to write. Now I'm going to write what is z6. What is z6? Z6 will be containing 6 elements. So try to understand this concept. When I write 6 here, I should have 6 elements in that particular set. If I have 10 here, I should have 10 elements here in this set. But the elements of the set should start from 0. So 0 means 0, 1, 2, 3, 4 and 5. I will stop at 5. Because if I include 6 over here, the number of elements in the set will exceed 6. So since I am starting it from 0, I will stop at 5. So this can be same for all those modulo declaration. Suppose if I write Z10, I'll be starting from 0. Where should I end up? I'll be ending up at 9. Okay. Now we shall verify and find the roots. So how are we going to find the roots? So what we do here, we have 6 elements, right? So take element by element, one by one and substitute in this f of x. So first I take 0, substitute here. If I substitute here, what will I get? 0, 0 and 2. So I'm writing it 2. Okay. Next take 1. Substitute 1. 1 plus 3 plus 2. So what's my answer? It's 6. So I'm writing 6 here. I'll come to the modular division later. Now coming to 2. If I substitute 2, it's going to be 4 plus 6 plus 2, which is 12. Coming to 4, I'll be getting 4 square. 4 square is 16 plus 12 plus 2. So it's going to be 30. And the last one, 5. If I substitute 5, it's going to be 25 plus 15 plus 2. So it becomes 42. Is that clear? So first, whenever a modulo thing is mentioned, you write down all the elements and start substituting one by one in your function f of x, and first you tabulate it. Now comes the discussion under modulo. Now what do I do? First, since modulo is given, I go and find out whether what is the answer I'm getting here. So if I see the answer here, the answer I got it is 2. 2 is less than the modulo 6. Is that clear? So it's a less than number. It's a smaller number than 6. So I cannot divide or cannot do anything with that with that 2. So I'll write the answer is not equal to 0 because 2 is not equal to 0. Is that clear? Right. Now coming to the second one. What is the answer I got? The answer I got was 6. So 6 is equivalent to that 6, right? When I divide 6 upon 6, I can divide 6 upon 6. If I'm going to divide 6 upon 6, what is my remainder? Remainder is 0. So this is a congruent symbol where I write 3 lines. Okay. So what I should write the remainder in under what modulo I have done it. For 12. 12 is divisible by 6. So what is the remainder? 0 again, mod 6. Now coming to 20. If I take 20, if I am going to divide this by 6, how many times? 3 times. 6 3s are 18. Right? So what is the remainder? My remainder is 2. So now coming to 30. 30 is clearly visible by 6. So if I am going to divide 30 upon 6, I will be getting 0 remainder. I am writing only the reminders. Make a note of it. It's not the quotient. Now coming here, 42. If I am going to divide 42 over 6, it's perfectly dividing because 6 8s are 48, 42 and the remainder is 0. So I am tabulating the 0. So here After, see, first step is I had written all the elements in Z6. Second step is I have started substituting all the elements in Z6 in my f of x and noted the values. Third step, I have applied the mod function and I found out the remainder here. And now I'm going to give my declaration or my conclusion. So what will be my conclusion will be, so 0 is not a root. Why 0 is not a root? Since I substitute 0, I'm not getting a answer as 0. Only if I substitute one value and the answer is 0, then only I can declare it as a root. So my answer is not 0, right? So 0 is not a root. Now if since I substitute 1, what is my answer here? 0. So 1 is a root. 2 I substituted, my answer is 0 here. Look at the remainder. So therefore 2 is a root. 3 I substituted, the remainder is 2. So it is not a root. 4 I substituted, the remainder is 0. So 4 is the root. 5 I substituted, 5, the remainder is 0. So 5 is the root. So you just finally conclude, therefore the roots of f of x are 1, 2, 4 and 5 under the modular division of Z6. Is that clear? So third problem, same type of problem. Find all the roots of f of x is equal to x square plus 4x in Z12. So in Z12, what will I write? 0, 1, 2, 3, 4 up to 11. So what do? I start substituting one by one. So first I substituted 0 here. If I substitute 0, the entire answer will be 0. So automatically I can say when my answer is 0, I can say that particular element is a root. Second, substitute 1. If I substitute 1, the answer is 5. 5 is definitely less than 12. So I can't divide 5 upon 12. So it is not equal to 0. Therefore 1 is not a root. Substitute 2. 2 if I substitute is going to be 2 square is 4. 4 into 2 is 8. So 4 plus 8 is equal to 12. 12 can be divided by 12. It's just perfectly dividing and my remainder is 0. So since my remainder is 0, I can call this 2 as a root. Same way for 3. 3 if I'm going to substitute is going to be 9 plus 12. So my answer is 21. And if I'm going to divide 12, okay, 21 by 12, my answer remainder will be 9, which is not equal to 0. Therefore 3 is not a root. Clear? Likewise, you start substituting for 4. 4, the answer is 45. For 12, the remainder is 9. Not equal to 0. So 4 is not a root. Similar way, f of 6. Okay. Likewise, you just keep dividing, substituting each number and get the value and divide it by 12. Okay. So divided by 12. How many times over here? So dividing and you're getting it a remainder as 5. 96 is perfectly dividing by 6. 117 will not be divisible by will not be divisible by 12. Likewise, for each number you start dividing and finding out the remainder. The very simple fact is, when you get the remainder as 0, you call that particular element as a root. If not, you call it is not a root. So finally jot down all the elements which are the roots of f of x over Z12. Thank you so much. Hope you understood the roots of polynomials.